Hello everyone, this is Rasta from Stephen. This is a college of engineering. Today I'm going to do a video assignment on stack operations. Let us deep dive into stack data structures in its operations, implementations, and applications. We'll also explore the LIFO principles and analyze time and space complexities. So, overview of a stack data structures. A linear data structure that follows the LIFO principle, last in, first out, is called as stack. So the main operations of stacks are push, which is adding an element to the top of the stack, and pop, remove the topmost element from the stack. So let us take a common example. Uh, Let us be practical. There are many real life examples of stack. Let us consider a simple example of plates. So as you can see the plates, we will take an example of plates stacked over one another in a canteen. Plate which is at the top is the first one to be removed. The plate which has been placed at the bottommost portion remains in the stack for the longest period of time. So it can be simply seen to follow the LIFO, which is last in, first out. So the first plate will come out and the last plate will come out after completing every stack operations, after lifting every plate till plate 10. So simple representation of stack with push and pop operations. As you can see, this is an example of a tower of Hanoi where the disks are placed. We can say it's post, it's pop, it post. We'll learn about it in the further slides. So let us see what types of stacks. There are two types of stacks, fixed sized stack and dynamic size stack. So size stack has a fixed memory or it has fixed size and cannot grow or shrink dynamically. If the stack is full and an attempt is made to add an element to it, an overflow error occurs. If the stack is empty and an attempt is made to remove an element from it, an underflow error occurs. So dynamic size stack. A dynamic size stack can grow or shrink dynamically. When the stack is full, it automatically increases its size to accommodate the new element. And when the stack is empty, it decreases its size. This type of stack is implemented using a linked list as it follows for easy resize of the string. So basic operations on stacks. So in order to manipulate the stack, there are certain operations provided or inbuilt. So these are push, pop, top, is empty, size, which are all user-defined things. So the push is used to insert an element into a stack. This is an element which is inserted in a stack. So pop to remove an element from the stack. To remove the element out of the stack, we use pop. So top returns the top element of the stack. So top is the topmost of the stack or the element which can be uh, inserted or it can be brought out. Then is empty returns true if stack is empty, else false. If the stack is empty, the is empty function returns true. If it is not, then it returns false. The size returns the size of the stack. You can take the size as 5, 6. The size function returns the size of the stack. Stack.DT, which is abstract data type. So abstract data type of stacks are the instance. First, we'll look into the instance. Linear list of elements. One end is the bottom and the other is the top. So operations are empty, then size, then top, then pop, and push. So let us dive into the push function. The stacks up in a new item. A stack overflow circumstances is when the stack is completely full. So algorithm for push is, let us begin. If stack is full, okay, return stack or return nothing. Else increment top. We must increment the top and stack top assign value. So we must assign stack top value to it. Item will go into this and when the items go into this. This stack top is fill it inserted, then and else, then pop. It takes something out of the stack in the opposite sequence from which they were pushed. The things are pop. The conditions is referred to as an underflow if the stack is empty. Let us see the algorithm for pop function. Begin. We'll begin the function and we'll begin the program. If stack is empty, then return. Yeah, absolutely. When the stack is empty, we cannot uh, pop the item. So we'll return -1. Then else store value of stack top. So what we'll do is stack of top will be inserted into the item and decrement the top. So we go on decrementing step by step and will return the stack of top, return the item in the pop function. So this is an empty stack where nothing is there in this stack. You can see here the top is -1, which is nothing. Then the element 10 is added. So this becomes the top. Then next, the element 20 is added to the stack itself, the push operation to 20. So the top becomes as 20. Then the pop operation is called. When the pop operation is called, the 20 comes out of the stack. So this is the operations of push, pop, isEmpty, and size, and many more. So how do you implement in the arrays? So why do we implement in arrays? So let us see the advantages and disadvantages. So advantages are simply simple and efficient storage and random access to elements. Fixed size, stack overflow can occur. You can see the stack are converted to arrays to implement, and these are mainly used to access to the random elements and the to save the storage. We use arrays. You can see the array operations in this figure. The stack is empty. Then the top zero, which is 100, is added. Then 200 is added to the stack. Then 300 is added to the stack. Then the what is going on is the one is changed to which is the 300 is changed to 500. Then the 600 is added. So this is the array implementation. Next, we'll dive into the implementation of linked list. Why do we use linked list? We'll see advantage and disadvantage. We use linked list because it contains dynamic size with efficient memory utilization, no stack overflow. Next, the disadvantage or limitations are extra memory overhead, no random access. So these are the advantages and limitations of linked list. So we use linked list to do the stack operations by linking the data and linking the data to the next and so on. The first data is the top, and the last is the last minus or zero of the stack. So this way, the linked list is applied or implemented in the stack. You can see the figure. This is the representation of stack using list. So top of the stack is 10, then 25, then 8. So in how do we implement in list? We take the head. Head is a special thing taken in the linked list itself. So we take the head node and we add the 10, right? Then the address is called to 45, then we have 25, so 8, then null. So this way, the 10, 45, 8 is added in linked list using stack implementation or representing stack. So let us see time and space complexity of analysis. What is the time complexity? Time complexity plays a major role, which where we check the time taken by the code to run the particular function. The space complexity is the space taken when the n number of operations are done in the code. So the push operation time complexity is O of big O of 1, and space complexity is big O of 1, which is very good. Then pop is time complexity is O of 1, and space complexity of 0 of O. And search and access is searching your elements is Time complexity is O of n, and space complexity of n. So let us see the applications of stacks in data structures. We use in expression evaluation, like reverse of Polish notations, calculator, infix, and postfix conversion. We use function called stack, like the recursion which calls itself, and backtracking algorithms. Yeah, deep search, the first search. We use the stack operations. We do undo redo functionality stores the history of the actions to enable undo redo operations. So these are the applications. And infix and postfix stacks. This type of stack is used to convert infix expression to postfix expression. Expressions evaluation stack. This type of stack is used to evaluate postfix expression. It is mainly used to evaluate the postfix expressions. And recursion stack. This type of stack is used to keep track of function calls in a computer program and to return control to the correct function when a function returns. Memory management stack. This type of stack is used to store the values of the program, counter and values of the registers in a computer program, allowing the program to return to the previous state when a function returns. Balance parenthesis stack. This type of stack is used to check the balance parenthesis in an expression. So undo redo stack. This type of stack is used in computer programs to allow users to undo and redo actions. So what we have learned in this video, we learned of the stack basics, we learned about the last in first out principles and main operations of put and pop, isEmpty, price, many things. We learned about the implementations. Array provides simple storage and linked list and offers dynamic size. It avoids stack overflow. We also saw the time and space complexity of push and pop operations in the stacks, and these are the things we learned today. So thank you. Have a nice day. Do like and do comment. Thank you. Have a great